Hi everyone. Today I would like to solve one example for the MMSE estimation. In this example, I would like to estimate a random variable x, or let's say x1, as a linear combination of random variable x2 and x3, right? So in the last video, I introduced you the concept of MMSE. If you have not already watched that video, I will put a link in the description. Definitely watch that video. Toward the end of that video, I solved one example on how to estimate a random variable x using a constant. And I also outlined the steps on how to solve any MMSE estimation problem. Okay, so let's start this video by this example. Find the MMSE minimum mean score estimation of the random variable x1. Find the MMSE of random variable x1 in terms of linear combination of random variables x2 and x3. Okay, great. So that's a question. You would like to find the MMSE of random variable x1 in terms of linear combination of x2 and x3. So let's follow the steps that I outlined in the last video. Okay, let's start. So step 1, define the estimator. What does it mean? It means that x hat is equal to a1 x2 plus a2 x3. Wouldn't that better if I just use the same? I would use a2 and a3 x3, right? So that's our estimator, right? Linear combination of x2 and x3. So that's the most important step. If this step is wrong, the rest of the procedure, if you apply that, then you will get a wrong answer. First, you need to have a right estimator. Good. Step 2, construct the MSE. Remember what was the MSE? MSE was expected value of residual square, which is this. And this problem is this x1 minus x hat square. This is what MSE is, mean square error. Now, step 3, first I will tell you the steps and then we will go to each step in detail. Step 3, differentiate the MSE with respect to A2 and A3, right? But x2 and x3 are the random variable given. So once we find the optimal coefficient, then we are set. Differentiate the MSE with respect to A2 and A3 to find the optimal coefficients. Okay, now in this problem, we don't really care about the MSE, mean square error. So we can actually leave it as it is. We don't have to plug the actual coefficients in the MSE expression to find the optimal MSE. But that was the step 4 that I outlined. And some problems are important, right? Some problems, for example, you get a very nice formula. In this problem, we just want to find the optimal coefficient. We want to find the MMSE. MMSE is after you find this A2 and A3, then x hat becomes MMSE. After you plug the optimal A2 and A3, then you get the MMSE. Okay, so that's the question that we are trying to find. Great. So part one, step one, we already know what we are doing. We already know the estimator. Let me switch to another color here. So step two, we write these, we write this, x1 minus a2 x2 plus a3 x3 all together square. Right. Without going to step three, first, before that, we need to be able to expand this expression and simplify it a little bit. Right. Okay, so let's do this one here. This is going to be expected value of first x1 square. Take the entire this term, if it's you want, take it to be like x4. So it's going to be this term square. It's going to be a2 to square, x2 square, a3 square, x3 square, plus 2a2, a3, x2, x3, minus now 2x1, a2, x2, plus a3, x3. Great. Okay, now let's use the property of expectation. We know expectation is a linear operator, right? So we can actually bring expectation inside the bracket here, right? So note expected value of x plus v, y is equal to expected value of x plus expected value of y. It's just a note that we can actually separate the expectation. Good. So what we get here is expected value of x1 square. We know a2 and a3, they're unknown parameter, but we know that unknown value we are trying to estimate, but they are not random variable. x2 and x3 are random variable, right? So a2 and a3 are deterministic, unknown but deterministic. So we can take them out of the expectation. A2, x1, x2, minus 2a3, expected value of x1, x3. Okay, perfect. And this is after I expand. Okay, so I go to a step 4 now. A step 3, sorry. What is a step 3? Differentiate step 2 with respect to a2 and a3 and set them to 0. First, respect to a2. Well, respect to a2, that's where the round is important, because now a2 and a3 are both of them are unknown, so there are two parameters here. So respect to a2 means that a3 is constant. You get 2a2 expected value of this x squared plus 2a3 expected value of x2, x3 minus 2 expected value of x1, x2 equal to 0. Let's write it like this. The second one, the second equation, we're gonna take it respect to a3. Let's set it to this way. So for this one, you get 2 a3 plus 2a2 minus 2 x1 x3 equal to 0. Okay, now we have a system of equations, two equations, two unknown, right? A2 and A3 are our unknowns, and we have two equations. Okay, so let's write this one as a system of equation. Let's use another color. So before writing as a system of equation, let's see that the equation 1 and equation 2 are all both divisible by 2. So let's make sure that we are first dividing them by 2 before doing this. The unknown is gonna be A2, A3, and this is gonna be our right-hand side. Okay, so as I said, we are already divide everything by 2. Then first we're gonna find this, the parameters that we have to. So this one is gonna be this side. I'm gonna make it a little bigger. This is gonna be this, and this is gonna be expected value of x2, x3. Right. For the other equation, I am going to have expected value of x2, x3, and the other one I'm going to have expected value of x3 squared, so x2. And here I am going to have expected value of x1, x3. Perfect. So this is like a system of equation that can easily be solved even by hand, because you have two equations to unknown. Take this one as a, take this one as x, take this one as y. You are trying to solve ax equal to y. The solution here, x is equal to a inverse y, right? But how do you calculate a inverse? How do you calculate a inverse? So when you have a 2 by 2, I will write a note here. If a is a, b, c, d, then a inverse is 1 over determinant of a, then swap the main diagonal d and a, and then negate the element of the not the main diagonal, right? Okay. So negative c and negative b, and also determinant of a is what here? Determinant of a is ad minus bc. So we do the same thing here. So here, first let's find the determinant of a for our case. What's the determinant of a? Determinant of a is this minus right. That's the determinant of a. And so in a sense, a inverse if I write it better here, I would just write 1 over the determinant of a. And now let's swap these two. This swap the element of main diagonal. Remember, there was the equation we had. And then negate each one. Okay, so this is going to be A inverse. Therefore, x in our problem, capital X here, is not random variable, it's that unknown that we have. Perhaps the time to change this one to z, perhaps. Maybe x is confusing. I will write az is equal to y, A inverse. So therefore z is equal to this. So therefore Z is 1 over, it's time to use this one here, copy this one and paste it. And then Y, just put it here, EX12 and X1. Okay, so that's how would we actually calculate the coefficient. This is gonna be corresponding to A2, A3. So in a sense, if you want to continue further, A2 is going to be what? This one is gonna be the same for across A2 and A3. This is gonna be this. Yeah, this is gonna be this. It's gonna be the first one. So if you multiply that, you get this one. I'm going to write it in the numerator here. It's gonna be expected value of x3 square times expected value of x1, x2 minus expected value of x2, x3 times expected value of x1, x3. So that's gonna be this. That's going to be A2. And then A3, remember the denominator. It's the same. So we just need to fill out the numerator. This row is gonna be multiplied by this one. So it's gonna be E of x1, x2. First, I'm gonna write the positive side, 3 times E of x3 squared minus E of x1, x2 times E of x1, x3. And this is gonna be A3. So this is gonna be our optimal coefficient if we use the MMSE. This is A2 and this is A3. So this was a pretty good example on how to estimate a random variable using linear combination of two random variables. You can expand this one to n random variables. The procedure is the same, and you can follow the steps that I outlined here or in the last video to calculate the MMSE for any two for any actually problem. Now in the next video, I'm going to talk about the MMSE estimation given that I observe a random variable, another random variable. So I have more information, right? I have already observed a random variable. And also I'm going to talk about the orthogonality principle, which is an extremely important concept in terms of the estimation problems. And then we will talk about the linear MMSE maybe in the future videos. And then we can actually finish the concept of MMSE and move on to the least square estimation. So that's it for this video. If you like this video, please subscribe to this channel and like and share the video with anyone you like. I have also written an article that go at the same time with this video. I will put a link in the description. Please check out that article. For more explanation in the article, there are some simulation and some examples. Hopefully you have enjoyed this video. See you guys all in the next video. Thank you.